6.1, 6.2e. Okay, so far that we've seen fx equals the partial of z with respect to x. Well, another way of writing this is just like this. Okay, so I don't want you to get confused when you see on the homework all these different symbols. Okay, so here's an example. Okay, we're going to take the partial with respect to x of x squared y plus y ln x plus y. So when we do this, remember y is the variable, x is the variable, y is constant. Just pretend it's like a number when you're figuring it out. So taking the derivative here, this is our variable, this is our constant. So our answer is going to be 2yx. We bring down the 2 times y, and then bring our x over. Okay, next one. Y is constant. This is our variable, so we're going to keep our constant y and take the derivative of ln of x, which is 1 over x. Y is constant. The derivative of a constant is just 0. So our end results, 2yx or 2xy, doesn't matter, plus y over x. Okay, let's do the same thing now, but we're going to take it, I'll write it over here. We're going to take the partial with respect to y. X squared y plus y ln x plus y. Okay, now y is the variable and x is the constant. If x is the constant here and we take the derivative, we're just left with x squared. Y is the variable, x is the constant. So once again, the derivative here would just be ln x because x is the constant, so ln x is a constant. And the derivative of y is just 1. Okay, so notice we have two different answers, which makes sense because we're making two different slopes for two different tangent lines going through the same point. Okay, let's do another problem. Okay, so this is another problem, something you'll see in your homework. Z equals 7x squared y plus e to the 3y minus ln x. Okay. Then in that same type of problem, it'll say find the partial derivative of z with respect to x, partial derivative of z with respect to y, and then they'll say the partial derivative of x at point -2, -1, partial derivative with respect to y at point 0, 4. Okay, so this is a point that we're going to input once we take care of this, and this is a point that we're going to input once we take care of that. Now this is what they told us z was. Okay, so let's do the first one. Partial z with respect to x equals. This means x is the variable, so x squared is a variable, and 7 and y are constant. They're just like numbers. So we have 7y times 2 times x. We bring down the 2, multiply it by 7 and y. All right, x is the variable, so this is a constant, so that's just 0. X is the variable minus 1 over x. Okay, so this equals 14yx minus 1 over x. Now let's do this problem right here because we already have our formula out. Here we go right here, our equation, I should say. Okay, so the partial with respect to x of the point -2, -1, we're going to put a -2 wherever we see an x and a -1 wherever we see a y. So 14 times -1 times -2 minus 1 over -2. So this is positive 28 plus a half which is 28.5. Okay, now let's go the other way. We're going to take the partial derivative with respect to y. Okay. Y is the variable. This is all constant now. So 7x squared. Y is a variable. So we have e to the 3y. Take the derivative times 3. This is just a constant plus 0. So we have 7x squared plus 3e to 3y. And now we're going to do this right here. The partial with respect to y at the point 0, 4. We put in the point, put in 0 in our x, and put in 4 in our y, which is 0 plus 3 times e to the 12. And if we put this in our calculator, this comes out to approximately 488,000. Boy, what a steep slope this is, huh? 264.4.